You hesitate for no obvious reason. You choose a different road. You call someone at exactly the moment they need you. Later, it feels as if something guided you. Was it intuition, coincidence, luck, or fate? Science has never discovered a measurable force called destiny. But neuroscience and chaos theory reveal something almost as strange. Your brain is constantly predicting the future, narrowing possibilities and pushing your life towards certain outcomes. And when tiny variations remain, one glance, one neuron, 1 second of hesitation, they can redirect the entire trajectory. Perhaps fate is not a script written outside us. Perhaps it is the shape of the possibilities inside us. We often imagine perception as a camera. The world sends information in, and the brain records what is there. But according to predictive processing theories, perception works differently. The brain does not passively wait for reality. It continuously generates predictions about what is happening and compares them with incoming sensory signals. You do not simply see a face. Your brain predicts a face, then updates that prediction using light entering your eyes. You do not merely hear a sentence. Your brain anticipates the next word before it arrives. Every moment becomes a negotiation between expectation and evidence. In this view, the brain is less like a camera and more like a simulation engine. It is continuously asking, what is most likely to happen next? Predictive coding proposes a hierarchy. Higher brain regions generate broad expectations. Lower regions process detailed sensory information. Predictions move downward. Prediction errors move upward. A prediction error is simply the difference between what the brain expected and what it received. If you expect a quiet room and hear a crash, the error is large. If you expect your friend's voice and hear exactly that, the error is small. The brain then has two basic options. It can update its model. I was wrong about the world. Or it can act, I will change the world until it matches my prediction. This second possibility becomes central to active inference theories. You predict that your hand will reach the cup. Your motor system moves until your sensory input matches the prediction. The brain does not only forecast reality, it participates in creating the next moment of it. Every prediction changes behavior. Behavior changes the environment. The environment returns new evidence. And that evidence changes the next prediction. A loop forms. Prediction, action, consequence, learning, prediction again. Over years, these loops produce habits, expectations, and identities. Someone who expects rejection may avoid eye contact, speak less, and leave social situations early. Other people respond to that behavior. The person then receives evidence that social connection is difficult. The prediction appears to come true, not because the universe obeyed a thought, but because the thought altered action, and action altered probability. This is a scientifically grounded form of the self-fulfilling prophecy. The brain can help construct the future it expects. To connect this with fate, we need chaos theory and dynamical systems. Imagine every possible state of your brain as a point in an enormous landscape. Thoughts, emotions, and decisions move through this landscape like a ball rolling over hills and valleys. Some valleys are shallow. The mind leaves them easily. Others are deep. Once neural activity falls into them, it tends to remain. Scientists call stable patterns like these attractors. An attractor might represent a remembered face, a familiar fear, a habitual response, a decision, a belief about yourself. The deeper the attractor, the more resistant it is to disturbance. That means your history helps shape the geometry of your future. Repeated thoughts deepen certain valleys. Practice strengthens certain roots. Trauma can make defensive states easier to enter. Training can make skilled actions nearly automatic. What feels like fate may sometimes be the momentum of a deeply learned nervous system. Science cannot measure metaphysical fate, but it can measure something close to what people mean by inevitability. Take the same system and simulate it thousands of times. Vary the small details: timing, noise, sensory uncertainty, minor environmental disturbances. If nearly every simulation reaches the same outcome, the result is highly robust. Small changes do not matter. The future is concentrated. Operationally, this is fate-like, not because an invisible power demanded the outcome, but because the structure of the system made alternatives unlikely. A highly trained pianist does not depend on luck to play a familiar scale. A strong habit does not require conscious deliberation. A person trapped in a rigid pattern may repeatedly arrive at the same result, even in different circumstances. Fate, in this model, is not prophecy. It is the stability of a path. Now imagine the ball is balanced near the boundary between two attractors. One side leads to action A, the other leads to action B. Far inside a valley, a tiny disturbance changes nothing. At the boundary, almost anything can matter. A sound, a memory, a fraction of a second, a subtle shift in attention, a small fluctuation in neural activity, a barely noticed facial expression. One extra spike in a network of neurons will not normally transform a life. But in a nonlinear system near a decision threshold, a tiny variation can decide which larger process begins. This is where luck enters, not as magical energy, but as the influence of uncontrolled variation when multiple futures are still almost equally possible. Chaos theory is often misunderstood. A chaotic system is not necessarily random. It may follow precise deterministic rules, but small differences in its starting condition can grow rapidly. This is sensitive dependence on initial conditions, the famous butterfly effect. The butterfly does not magically create a hurricane. It changes which permitted atmospheric trajectory occurs. The storm still requires pressure, humidity, temperature, and energy. The tiny disturbance matters only because the larger system is already capable of amplification. The same principle can apply to behavior. One accidental meeting can alter a career. One delayed train can prevent another encounter. One unusual neural fluctuation can change a decision, but tiny events only become powerful when the surrounding system is prepared to magnify them. Luck requires leverage. Brains are variable. The same neuron does not always respond in precisely the same way. Attention fluctuates. Reaction times change. Networks contain spontaneous activity. Traditionally, this variability was often treated as biological imperfection. But variation may also be useful. A perfectly rigid brain would repeat its strongest prediction endlessly. It could become trapped in one interpretation or behavior. Some variability allows exploration. It helps the system test alternatives. It can push the mind out of an unhelpful attractor. In certain nonlinear systems, a small amount of noise can even improve detection of a weak signal. This phenomenon is called stochastic resonance. Too little variation, and the signal may remain below the threshold. Too much, and the signal disappears in noise. But under the right conditions, randomness helps information become visible. The thing we call mental noise may sometimes be part of the brain's search strategy. This is where scientific and esoteric interpretations often meet. People report intuition as a feeling that appears before conscious reasoning, a sense that something is wrong, a pull toward one decision, a dream that seems meaningful, a coincidence that feels too precise to ignore. Science does not establish that these experiences reveal a supernatural future, but predictive processing offers another possibility. The brain may detect patterns before conscious awareness can explain them. It integrates posture, tone of voice, timing, memory, and context. The conscious mind receives only the conclusion: leave, wait, call this person, do not trust that situation. Sometimes the unconscious model is accurate. Sometimes it is distorted by fear, prejudice, or expectation. The subjective feeling can be identical in both cases. This is why intuition can be powerful without being infallible. It may be compressed inference, not prophecy. Carl Jung used the term synchronicity for meaningful coincidences that appear connected without an obvious causal mechanism. Modern science has not confirmed synchronicity as a force linking mind and external events. But the experience of meaningful coincidence is psychologically real. The brain is designed to detect patterns. It evaluates events according to personal goals, memories, and emotional significance. A coincidence involving a stranger is forgotten. The same coincidence involving a lost friend may transform a life. Meaning does not exist only in probability. It also exists in interpretation. Two people can experience the same event and enter entirely different psychological trajectories because their brains assign different significance to it. The event may be accidental. Its influence is not. A coincidence can become a prediction error so powerful that it forces the brain to rebuild its model of reality. Luck and skill are not opposites. Skill changes the landscape in which luck operates. A trained person creates more routes toward success. An experienced doctor notices subtle evidence that another person misses. A practiced musician can recover from an unexpected mistake. A prepared entrepreneur can recognize an opportunity that looks meaningless to everyone else. Training deepens useful attractors. Knowledge improves predictions. Experience increases the number of favorable responses available when something unexpected happens. This leads to a powerful formulation. Skill creates favorable basins. Luck helps select the path through them. You cannot control every disturbance, but you can build a system in which more disturbances still lead somewhere useful. That is resilience. And resilience is a practical way of reducing dependence on bad luck. Imagine simulating the same decision 10,000 times. The person has the same history, knowledge, and goals, but the simulations vary tiny details: neural activity, timing, background sounds, external events, sensory uncertainty. Suppose 95% of the simulations lead to the same choice. That decision is highly robust. It is fate-like. Now suppose the outcomes are divided almost equally. The system is near a boundary. Small variations have great influence. It is luck-sensitive. To measure favorable luck, compare the actual result with the entire distribution. Was the outcome better than expected? How unlikely was it? Would it still have happened if the uncontrolled variations were removed? This does not reveal cosmic destiny. It measures counterfactual dependence. How much did the result depend on details no one controlled? If our brains are prediction systems shaped by prior causes, is choice an illusion? Chaos theory does not solve the philosophical problem of free will, but it shows why the alternative is not simple. Behavior is neither perfectly predictable nor unrestricted. We act inside constraints: biology, memory, culture, circumstance, habit. But action also changes those constraints. Learning reshapes priors. Practice alters attractors. Therapy can weaken rigid patterns. New environments create new evidence. Reflection can interrupt an automatic prediction before it becomes behavior. Agency may not mean acting without causes. It may mean becoming part of the causal process that changes which futures are probable. You may not choose the original landscape, but you can sometimes reshape it. So where do fate and luck remain inside the brain? Fate is the robustness of the path. It is the force of priors, habits, attractors, and circumstances that keep returning the system to the same destination. Luck is the unresolved variation. It is the tiny difference that still has the power to redirect the trajectory when the system stands near a boundary. And agency is the ability to learn, prepare, and act so that more possible paths lead somewhere worth reaching. Science does not prove that the universe has written your future. It reveals something more complicated. Your brain predicts reality. Your predictions influence action. Your actions modify the world. The world sends back surprises. And somewhere between structure and uncertainty, one future becomes real. Perhaps fate is not a chain pulling us forward. Perhaps it is the landscape beneath our feet, and luck is the nearly invisible step that decides which side of the ridge we descend.